Okay, class, we're going to do a lesson on linear functions, and this is supposed to be some prerequisite material, but many of you may not have seen this in a while, and even if you have and you feel pretty sharp on it, we're going to make sure we truly understand what each of those terms in the phrase a linear function means and build on that throughout the class. Okay, so linear function. So we want to make sure we understand each piece, linear and function. And the word linear, usually no problem, everyone can handle that. Line, right? It's got it right in the word there. So it's a straight line. And so we want to try to see if we can, for a moment, remember everything we can about lines, and then we'll come back and think about what the function part does. So pause the video and take a moment to just, in 2 minutes, give yourself a time limit, write down everything you can remember about lines. Right, wrong, it doesn't matter. We're just going to get the longest list we can, quickly get it out. And then when you're ready, after the 2 minutes expired, unpause and we'll see how we did. And we'll start working through some of the things that we remembered. And so linear functions, a straight line, hopefully you started maybe just graphing one. All right. This is in what's called the Cartesian plane, the XY axes, and we're graphing things. And we will spend almost all of your math career has been in the XY plane. Maybe you'll continue on and take some more math, in which case you'd expand to things that live beyond the XY plane into the three-dimensional world that we all walk around and live in. And that would be when you get into, say, Calc 3 and some later parts in your business major. You might see some three-dimensional functions. For now, though, in this semester, we're going to be here in the XY plane, talking about lines. And so we drew one here. What's something you remember about this? Does this have positive, negative, zero slope? Because it's leaning in this direction, it has positive slope, as opposed to something leaning like this, negative slope. And if it is a horizontal line, it has zero slope. And hopefully you also remember the notation that we often use. Linear functions are of the form y equals mx plus b. This is the general form of a line, also called the slope-intercept form of a line, because this here is your slope, m is the notation we usually use, and this is your y-intercept. So if I want to graph the line y equals 4x plus 1, the y-intercept is at 1, so the 1 unit here. I know that's 1 point on the line. How many points do I need to truly define a line? 2 points, so I just need to get another point, connect them, and I've graphed the line. And so in this case, the slope is 4, and you can think about that as over an invisible 1. And why do we write it like that? Is because you probably remember something called rise and run. Your slope m is rise divided by run. Rise means how much I go up. Run means how much I go left or right. Okay, in this case, we're going up 4 over 1. So 1, 2, 3, 4, up to the point 5. And we run over 1. So the next point on the line, I have 2 points, I connect them. Oops, not a very straight line. That's the line y equals 4x plus 1. We know that we run this way because it was a positive leaning line. So that's one thing you have to have in your memory bank. Positive leaning lines always have a slope this way. This one's a rather steep line because we have a slope of 4. If we said graph y equals 2x plus 1, that should be a little shallower, right? It shouldn't be quite as steep as this 4 because the slope is positive 2. So I'd start the same way at the same y-intercept. I'd go up 2 over 1 to this point, and that's the line y equals 2x plus 1. Okay, what's something else on your list that you remembered about lines? Suppose, let's take this next one, ones with zero slope that are horizontal lines. What do those look like? Those are always things of the form y equals, let's say, -3. if I want to graph the line y equals -3, there is no mx, so there's no x term in there, which means the slope is 0. And so anything y equals a constant would mean you go 1, 2, 3, -3. That's your intercept. And then it didn't say anything about x. So actually x is free to take on any value from -∞ to infinity, which sweeps out the horizontal line. So again, anything y is a constant makes a horizontal line. But what if we had x equals some number? So let's say x equals -4. We want to graph that one. So I go to -4 on the x-axis. 1, 2, 3, 4. That's all the information I have is about the x, where I live on the x-axis. It doesn't say anything about y, so y is free to take on any value from -∞ to infinity, which creates a vertical line. So that's the line, x equals -4. So now we have some information. If it's a y equals a number, y is a constant, that's a horizontal line with a 0 slope. If it's an x equals a constant, that's a vertical line. And what about the slope for that? So you may remember from a high school class that vertical lines are undefined in slope, or another way of saying that is they have no slope because they're so steep, they're not sloped at a grade. So this one, actually, in a way I remember it, is that they're north-south lines, and that's the no slope part. Or you can say they're undefined slope. Or you might have heard that they have infinite slope, because again, here's slope of 2, 4, 5, 6, keep on going, and you can go all the way up to like infinite slope. They all mean the same thing. Okay, so we have our slope-intercept form of a line, but maybe you had another form of a line that you remembered. So we'll put that down here. I'm going to go here. What if you have 2 points and they ask you to get the equation of the line? So this is a common question you also see. Find the equation of the line between the point 1, 2, and let's say -3. Okay, well, you can graph it and get an idea what it looks like. Because we're in 2-dimensional space, we can graph this. Go to the point 1, 2, -3, 1. And from the visual picture, we know a few things already. We know that the y-intercept is somewhere between 1 and 2. So the b part should be, so we can visually check our work, is somewhere between 1 and 2. We also know that the slope is positive because it's leaning this way. And we know the slope is probably a fractional value, like half, a third, something like that. It's not steep enough to be a 1 or a 2 or 3. It's definitely not a 0 horizontal line. So probably have a fractional value for our slope. Okay, so if we want to write it in this form, ultimately y equals mx plus b, again, we need to be a little more precise. We have some estimates for what b should look like, some estimates for what m should look like, but let's get precise. And so the slope is rise over run, but you probably also remember this formula, change in y over change in x, or y2 minus y1 over x2 minus x1, where x1, y1 is one of your points, x2, y2 is the other point. It doesn't matter which one you decide to call which. So maybe we'll say this is x1, y1, this is x2, y2. We always write our points as ordered pairs. Order matters, so we do the x first and then the y. So then we can plug into this formula. Doesn't matter, again, which one you chose. So we'll do y2 is 1 minus 2. And then x2 is -3 minus 1. So we'll have a -1 over a -4, which is a positive 1/4. That's our m. And I kind of checked with, again, with our hunches about this, that the slope should be a positive fractional value. Check, so that makes us feel a little better. The slope is 1/4. So we're halfway there to our formula. And we want to write this in y equals mx plus b form. We have part of it, 1/4 x, but we need to figure out the b, and then we'll be done. And how we can do that is b, so right now we have 3 letters in here, a y, an x, and a b. If I just had 1 letter and 1 equation, I could solve that. And so I could figure out the b. So I need to know an x and a y. So is there an x and y that we know that live on our line? Actually, there's 2 of them. Doesn't matter which one you choose. Let's choose the easy one, because 1 and 2 is always positive, so we don't have to worry about that, anything there. Choose that one to plug in. This is a point that lives on the line. So when x is 1, y is 2. Now I have 1 equation and 1 unknown, and I can solve it. On the pretest, you saw that you got to practice solving this equation. This is what is called a linear equation. We'll talk a little bit more about that when we come back to our title, linear functions. Okay, so we can solve this by moving some stuff to the other side. So this is 1/4 crosses this to the other side, becomes a negative 1/4. So 2 minus 1/4 is 7/4. I'm sorry. Yeah, that's right, 8. 7/4 is b. So now we have all the information to write it in y equals mx plus b form, our slope-intercept form, also called the general form of a line. And so we can say y is 1/4 x plus 7/4. That is the equation of the line, given those facts. So you have a lot of problems where they'll give you some information about a line. They'll tell you it's a line, they'll give you a point and a slope, they'll give you 2 points, they'll give you a point and a reciprocal slope, and you just want to get to the place where you can write it like this. When you write it y equals mx plus b and y equals, and in most of the equations this semester when we talk about the functions are y equals, so that we can enter them into a tool like a calculator or a tech tool that we'll talk more about this semester, like Wolfram Alpha, and we want to write it, this is called an explicit form of a function when you write it as y equals. So you want to solve for y, put everything else on the other side. Okay, so those are practice, some prerequisite material with lines, but it said we have to come back and understand both parts of this term, a linear function. And at this point in your math career, you've probably heard the word function so many times and just kind of take it for granted. But we want to really focus on dissect that word, deconstruct it, and make sure we completely understand what function means. Okay, so I'm going to erase the board and pause this so you have to watch me doing that. Okay, we're back for learning about the word function, the second half of our term. And we're ultimately going to contrast that with something that's not a line and nonlinear. So as long as there's any bends or curves, we're going to be dealing with nonlinear functions. Those are actually ones that are a bit more interesting to us. But we are always going to somehow relate these things because we're going to come back to something called a tangent line. See the word line in there. And so we're going to make sure we completely understand lines because we're going to use them over and over this semester. Okay, so we really spent a whole lot of time on the line linear part here. Let's work on the function part. And so we actually have written y equals mx plus b. Any linear function can be written in this form, but we're going to just make sure we also write in something you've seen before as well. Y, and we read this, y is a function of x, and then it's given by this formula, this linear equation. So what is a function? You may have heard it used in common language, like for instance, wisdom is a function of age. And so what does that mean? It just means that there's a relationship between wisdom and age. And that's what that quote means. We'll talk a little bit more about that also in this semester. Come back to that wisdom is a function of age. But for now, let's think about that function part. When we say wisdom is a function of age, it just says there's a relationship between these two variables. So when y is a function of x, there's some relationship. Give me an x, I'll tell you a y. Give me another x, I'll spit out another y. When it's a linear relationship, you give me an x and I follow this linear pattern and I spit out a y. So you can often think about y is a function of x. We just did 1/4x plus 1. And that's it. We talked about the graph of that. 1, 2, 3, 4 over 1, these 2 points. That's this line. You can also think about functions in a tabular form. I'm sure you've seen this before. Oops. X and then y is 4x plus 1. So again, it says that you input an x and it'll spit out a y. Another way of thinking about a function is in what's like a rule or a box form. In comes x, out comes y. You manipulate it according to what's in the function box. In this case, y is 4x plus 1. So you input an x, I'm going to multiply that x by 4, add 1, and spit out a y. So let's see how that looks. Let's put a couple things through this function box, which is also another way of building a table. So let's say we do a couple negative values, 0 and 1. So when x is -2, it comes into the function box, it follows the rule. So -2 times 4 is -8, plus 1 is -7. And we just continue going on. Let's do one more in the box rule. So x is -1. -1 times 4 is -4, plus 1, -3. 0 gives me a 1, 1 gives me a 5, and 2 gives me 9. And if we were to plot those points, those are all points on this line. We've actually already plotted a couple of them. 0, 1 is here, 1, 5 is here. 2, 9 continues up, -1, -3 is here. And so those are points on a line. Again, because it's a line, I only needed 2 of them to connect it and know what the whole graph looked like. So for the function rule, in the function box, you follow the rule. And for every x that comes in, there's only one y that comes out. And so this is something you may have seen called the vertical line test associated with functions. Something is a function if it passes the vertical line test. And all that means is whatever you've drawn, so I'm going to draw now over here a nonlinear function. Y is a function of x. I didn't give you an explicit algebraic formula for it, but you have a visual representation of it. Y is a function of x. Is that actually a function? I'm claiming it is, but to be a function, it has to pass the vertical line test. So what does that mean? That means for every x, there's only one y, which also means that any vertical line I draw through my function, through my graph, only touches the graph once. Yeah, so this passes the vertical line test, which implies it's a function. Check. Of course, every linear function, every line you draw is a function, right? Passes the vertical line test. What's a function that you've actually, or a graph that you've seen that actually isn't a function, but maybe you've done some analysis on it? Many of you have had to take a geometry class, so let's just think about a circle. Computer over here, yeah. Here's a circle with a radius of 1. Maybe you remember the equation of that. X squared plus y squared equals 1. This is actually not a function because it doesn't pass the vertical line test. I only need one line that touches for an x. So one vertical line goes through an x value and it touches the function twice, here and here. So this is not a function. Yet there are parts of it that we can analyze as a function. And so you've probably done this also in your math career. You've entered this circle into your calculator by splitting it into 2 parts. When you solve this equation for y, you got y squared equals 1 minus x squared. Y is plus or minus the square root of 1 minus x squared. So in your calculator, you enter the positive part, y equals positive square root of 1 minus x squared. Your calculator come around and graph that. That's the top half of the circle. That is y equals positive square root of 1 minus x squared. That is a function. It does pass the vertical line test. And then the other one, in your, if it's a TI calculator, you probably have like the y equals button, and there's a y1, and then you can enter another function they call y2. Let's put the -1 in there. And your calculator will come along and graph the bottom part. So you actually have graphed the circle by thinking of it. The circle itself is not a function, but you've graphed it by thinking of it as two separate functions that do pass the vertical line test. And again, a function just means a relationship between variables. In this case, we're only going to have two variables because we're always stuck in the xy plane. We'll have an x and a y, or a t and a p, time and profit that we've made over time, time and money that is in your bank account. So two variables, and they are related in some way. And if they can be defined in an explicit relationship with an algebraic formula that passes a vertical line test, they satisfy our mathematical definition of function. But the non-mathematical, just the generally used definition of function is that they are related. There's two things, time and money in my bank account, and they are related. Sometimes you have this algebraic explicit form. Sometimes you just have a visual graphical form. And we'll still be able to do analysis regardless. Sometimes you just have a table, and we'll still be able to do analysis. Okay, maybe let's spend a little bit more time with nonlinear functions, and then we'll do one more linear function. So I'm going to pause the video and clean the board. Okay, so we're going to continue with nonlinear function. So what makes, I want to make sure we can, throughout the semester, visually identify the difference between a linear and a nonlinear function right away by just looking at the algebraic equation. So let's take a linear function and then see what makes it a little bit different. So suppose this is clearly a linear function. It's in y equals mx plus b. Another way to recognize it is that there is, the x variable actually has like an invisible 1 in the exponent, right? That's the only power of x. And that's as opposed to y equals, say, x squared plus 1. Nonlinear because we have this square in the exponent. Cubes, square roots, that's another one would be nonlinear, right? E to the x, trig functions, right? So I'm just taking that original function and doing something where I'm modifying the, doing a transformation to the x variable that is a nonlinear transformation. And again, I want us to be able to recognize right away, all of these are nonlinear because they're not in the form y equals mx plus b. They don't have the x variable being linear, which is to say it's just an x. It might have a coefficient in front of it, that's fine, but it can't have any other manipulation of that x. So all of these are nonlinear. We'll learn how to graph some of the basic ones, but we'll also use tech tools as well. This one here, you maybe recognize, this is actually a special a nonlinear function that you may have studied well in a pre-calculus or even an algebra class. This is a parabola, opening up, going through 1. It's also called a quadratic equation because the highest power on the x is squared. So we have linears if there's like an invisible 1 power. We have quadratics if there's a square in an x. We have cubics, quartics, quintics. But we're going to spend most of our time with linears, quadratics, and maybe some cubics a little bit in this class. We'll get to this one. This is what's called an exponential function. Probably something you've seen before, but we'll get a chance to review it as we go along. Trig functions, we actually don't do much at all with trig functions. I could ask you a few concept questions, but we don't do calculating with trig functions in business calculus. If you were a science major, you'd probably see these much more often. Square root, yeah, we'll do things with square roots. You may remember from the pretest that this can also be written in its exponent form, right? Square root is the same thing as taking x to the 1/2 power. The square root function, again, you might also remember looks like this, has this like slow growth. This is y equals the square root of x plus 1. And if you don't remember that, again, it's okay. We're going to learn some tech tools. You can use your calculator. But there's always another way to graph a function in two-dimensional space, and that is by plotting points. So you could always do this table, like e to the x plus 1. Maybe you don't know what that looks like. Well, you can make this table. We can all do this. And this is function evaluation. This is tedious, and this is actually how a calculator and a tech tool does their graph, but they do a lot more points in their table. We're only going to put 3 or 4 or 5 in a table. They're going to probably put hundreds and then graph it that way. So you pick some values. You want to try maybe some negatives, some positives, put things that you're allowed to put in, which is your domain. What you get out, your range, is your y values. And so when x is -2, I follow the rule. So I need to know what e to the -2 plus 1 is. Put that in a calculator, or you can also use Google to do this kind of evaluation. So just show you some calculator functions of Google. We'll do a quick screen share here. So I'm at Google, and again, definitely this semester, fair game to use any of your tech tools if you're familiar with the calculator, or if you just do the equals in Google, e raised to the power -2 plus 1. And then you can see, make sure it's put it in correctly here, and we get 1.135. So that's the first point. And so we would graph point by point, if we do this table form, when x is -2, y is a little more than 1, so here. And we just keep accumulating a set of points until we saw what this graph looks like. Oh wait, why did it, yeah, -2, okay, yeah, that's correct. You have to get enough points, or maybe you already kind of know the shape of the graph, maybe from, again, the square roots you knew, or the parabolas. You just need a couple points to guide you. If you have no idea what it looks like, you're going to need to make a longer table, or again, use a tech tool. Okay, so one last thing I want to talk about. So nonlinear functions, we want to be able to recognize them and be able to build up a picture of what they look like. Let's just take a moment and think about a function. Let's do a age function. So I have a brother named Chad, and we're going to do my age versus my brother's. So I'm 2 years older than Chad, so we'll do a variable a for me, a for Amy, and then Chad. And so Chad's age plus 2 makes mine. So I want you to pause the video and make an age function that relates, maybe you have siblings, if you don't have any siblings, to a cousin or best friend, and make a function that relates your age to your friend or sibling's age. So pause the video, just take 30 seconds and do that. Make a couple if you have a couple siblings. I actually have another sibling named Chip, but that's his nickname for William, and we already have a C, so let's say. My age is actually William's -2. All right, now look at yours, look at mine. Is your age function linear or nonlinear? Is my age function linear or not linear? My age function is plural. And what we'll see when we're relating folks by their years, we're going to do it in this linear way. Again, you should easily be able to look at the equation and determine whether it's linear or nonlinear. And we also could have written this way, that age, Amy's age is a function of Chad's age. I take Chad's age and add 2. Right. Okay, so that is the first lesson on our prerequisite material, and then pretty soon we're going to move on to the calculus ideas. But one thing I find every semester is that it's often not the new material, the calculus, that trips folks up. It's this prerequisite material, which is linear functions, lines, functions in general, how to evaluate a function at a particular point, and then lots of algebra and factoring. And we'll review as we go some of the algebra and factoring, but if from the pretest you realize you're pretty far behind on those, it'd be a good idea to schedule some appointments with the math lab to brush up on those things. And one thing I just mentioned was function evaluation. Let's look at, let's squeeze under here, y equals f of x is x squared plus 1. Well, suppose I asked you, what if x is 5? This is evaluating a function. We often write it like f of 5, or we read it f of 5. It's just saying, plug into your function when x is 5. So you have 5 squared plus 1 is 25 plus 1 is 26. So function evaluation can happen for numerical values, numbers. Those are the ones we're a little more comfortable with. We just follow the rule. Wherever you see an x, you put a 5. But sometimes we'll ask you to do things like this. Evaluate f of x plus h. Well, this is now an expression, but I still follow the rule. I do the same thing as before. Wherever I see an x in my function rule, I now stick, instead of x, x plus h. So I'll have x plus h squared plus 1. You can write it like that, or you might simplify. And that would be x plus h times x plus h plus 1, x squared plus xh plus xh, 2 of them, plus h squared plus 1. So function evaluation is something, again, that often trips students up, but it's really not that bad. It's just following the rule that the function gives. All right, thank you.